Welcome to another STEM tutorial. In this video, we'll program the Newton method together in Python. We'll assume that you understand the Newton method algorithm, but in case you require a refresher on the method, you can watch our 10-minute Newton method algorithm explanation first. I'll post the link in the upper right-hand corner of this video and in our video description. For this programming example, we'll use the same example as in our explanation video. So let's get started. When programming the Newton method, the first thing I'm going to do is define my user-defined inputs. So this includes the initial guess required for step number 1 of our Newton's method algorithm. So like in our example, we're going to say that our initial starting value equals 6. So this is just our initial guess. It can be anything you like. We're going to define 2 additional values as well. The tolerance for our stopping criteria, which in our example is a value of 0.5, as well as the maximum number of iterations, which you can define to be as high as you like. So we'll say that our tolerance equals a value of 0.5, and this is our stopping criteria, and our maximum number of iterations, num of iterations, we'll say it's 20, but again, it can be as high as you like. For step number 2 of the Newton's method, we need to calculate our f of x and our f prime of x. So what we're going to do is we're going to define a function in Python to calculate our f of x and f prime of x. So for our f of x, we'll just call this function by the name of funct. You can call it whatever you like. And we're going to type the definition of our f of x value. So we see that our f of x value equals x to the power of 3 minus x to the power of 2 plus x minus 5. And with each call of this function, we'd always like the return value to equal our f of x. So we return f of x. So while programming, I always like to run my scripts by pressing this green play button up here to make sure that everything is running correctly. So if you run this file and you've typed everything the way I have, you should see no errors. And just to show the example of this function, you can also see whether or not this function is working correctly by just defining some example variable. So we'll say that our f of x value equals this function value, and we can input any x we like. So for instance, our value of 6. And if we look in our variable explorer, we'll see that our f of x value being calculated with this function equals 181. Okay, so everything's running fine. Now we're going to program our f prime of x value. So again, we're going to use another function definition to find that our d function is what I'm going to write for like d of x. Our d function of x will equal, and here what you can do is you can just write, for instance, that your d of x will equal the derivative of this function. So 3 times x to the power of 2 minus 2 times x plus 1. And with this you can return your d of x. So you can input the derivative of your function here manually to calculate your f prime of x. But what I'm going to do is I'm going to take a slightly different approach. I'm going to calculate the derivative of this function by estimating the slope. So like I said, you can take this approach. I'll show you another method as well. What we're going to do is we're going to take a small change in x to look at its impact on the change in our function values to estimate our d of x value. So this means you wouldn't have to always manually input your derivative function. So I'm going to say this small change in x value is going to equal 1e to the minus 2, and that our d of x value is going to equal our function value, so the change in our y value, so our function value of x plus the small value, and we're going to subtract the function value of our x minus the small value. And then we're going to divide it by the difference in our small values, which is small value times 2. Oh, and I see I forgot to write down small val. So now this red line disappears, this red X that we saw here. Now everything should be fine. So if we run this script again, we see that we don't have any error messages. So we'll just move on with our programming. Where we have our definition for our f of x and f prime of x, we can now program the iterative part. So I'll write a for loop. We'll say for I in range, and we're going to iterate from a value of 1. So we're going to start with a value of 1, since I'll be using the value of I for the message that we'll be printing with each iteration. So we're going to start iterating at a value of 1. We'll iterate up to our maximum number of iterations, our num of iterations, in an increment of 1. And with each iteration, we need to calculate our f of x value using this function definition here. So our function of x and our f prime of x value. So I'll call it df dx, which equals our d function of value of x. And with each iteration, what I'm going to do is I'm going to print a message stating the value of I and the value of f of x, just so that we can keep track in the display. So I'll print a message where I'll first of all state in which iteration we're in. So I'll write the string of I, and then I'll add another string to this value. I'll state the value of my x, which we know is just the value of x that we've calculated. So our first value of x is a value of 6. And then I'll also state the value of my f of x. And I'll print the value of the f of x value with each iteration. So this is really just to guide me on what's going on. And so we know with each calculation of our f of x, what we're going to do is we're going to compare our f of x value with our stopping criteria to see whether or not we can exit this for loop. So I'll write that if our absolute value of our f of x is less than this tolerance value here that we specified to be 0.5, you can change this to be whatever you want. The goal is to get as close to f of x equals 0 as possible. So if we've met our stopping criteria, we're going to exit this loop, so we're going to break. So despite maybe having put a very high number of iterations, it may be that you won't iterate for this maximum amount of iterations. You'll likely break earlier because you will have met your stopping criteria. And if we haven't met this stopping criteria, then we need to calculate the next x of our iteration. So from step number 2 of the formula, our new x will equal our x minus f of x divided by our f prime x. So df dx. And so with this, we've programmed our loop where we iterate for each new x value. And at the very end of the script, I'd like to write a message to state where the 0 is located. So I'll just write it down now, and you can copy it if you like to, but it's not necessary. If you're copying this snippet of code, please be careful and make sure to add all the plus symbols. If you see an X appearing over here in your spider interface, so I'll just delete this plus symbol, what you'll see is there's an error. I had this X in front of this line. Look closely to make sure that you copied everything correctly. It may be that you're missing one of these plus symbols where you're adding these different strings together. The same goes for this line. So having programmed the Newton method, we can now run our script. And what we see is we see each iteration, so iteration 1 to 5, and we see each of our x values and the corresponding f of x values. And with our final message, we find out that our 0 is located at an x value of 1.94. I could have written this nicer by saying x, and an f of x value of 0.48, and that it took 5 iterations to get there. So this wraps up our tutorial on programming the Newton method in Python. If you have any follow-up questions, please feel free to leave them in the comments section below. And if you enjoyed this video, please hit like and subscribe. Finally, check out our website stem-tutorials.com to access our free numerical methods course. Thanks for watching.